Today we will solve equations using the square root property. What the square root property says is that when I have a perfect square on either side of the equal sign, that I can take the square root of both sides of that equation so that I can find my factors. Now, there's a special thing when you take the square root of both sides. You have to add in the positive and the negative version, which I will show you in our examples. One moment. Here they are. Okay, example 1. If you're given an equation like x squared equals 100. X squared is a perfect square. 100 is also a perfect square. So to solve this, instead of factoring, I could take the square root of both sides. And over here where my number is by itself, I would include my positive and my negative version of the equation by putting a plus and a minus in front of the square root. The square root of x squared is x, because they cancel. A square root cancels a square, just like a cubed root would cancel a cube. Then I have equals, plus or minus, that's two different numbers, the square root of 100. In this case, the square root of 100 is simply 10. So I have two answers here. When I say x equals plus or minus 10, what I'm really saying is that x equals positive 10 or x equals a negative 10. There's two versions. I will accept this as your answer, but if you're one of those people that really likes to write it out, this is also acceptable, splitting it out into the two different versions. Let's do another one like that. Example 2. If I gave you z squared equals 32. Same thing, I have a perfect square over here. I don't have a perfect square on the right-hand side, but I can apply my simplifying radicals rules to simplify that. I do, however, have a perfect square for the variable, which is the most important thing. So I'm going to take the square root of both sides. On the right-hand side, I'm going to add that plus or that minus. The square root of z squared is z. Then over here, I have plus or minus the square root of 32. I cannot take the square root of 32, but I do notice that I can divide 32 by a number I can take the square root of. And if you take the factors of 32, you can split it into can and cannot. This is something that I showed you guys before. Can and cannot. I can take the square root of this number. I cannot take the square root of this number. So let's look at the factors of 32. I have 1 and 32. 2 and 16. 4 and 8. 5 doesn't work. 6 doesn't work. 7 doesn't work, and I'm back to 8. Okay? Then if I look at these factors, I'm going to identify all my perfect squares. Sorry, I'm just going to make this a little bit darker. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 16 is a perfect square because 4 times 4 is 16. Then after you identify all your perfect squares, you're looking for the largest perfect square. In this case, that would be 16. 16 is the largest perfect square. So I'm going to take that 16 and I'm going to put it under can. I can take the square root of 16. However, the 2 that 16 is being multiplied times, I cannot take the square root of. So that would go under cannot. So I have z equals plus or minus the square root of 16 times the square root of 2. Well, I'm going to simplify this. So I'm going to carry down my z. I'm going to carry down my plus or minus. The square root of 16 is simply 4. And I cannot take the square root of 2, so I'll leave that as root 2. And all I did was simplify the radical. And again, I'm okay with you writing the answer with plus or minus in front of the number. Let's do one that's a little bit different. Example 3. If they gave me x squared minus 25 equals 0. In this case, I don't have it set up so that I have that perfect square on either side. What I really have is a difference of squares. And we've already learned that a difference of squares can be factored. But I don't want to factor this. I don't have to. What I can do is move this number to the other side by adding. So add 25 to both sides. And when I do that, I'll get x squared equals a positive 25. Because that's a positive over here, and this is a perfect square, I can take the square root of both sides now. And on the right-hand side, I'll add in that plus or minus. Then the square root of x squared is x equals plus or minus the square root of 25 is 5. So I didn't actually have to factor the difference of two squares. All I had to do was take the square root of both sides once I moved the 25. Now let's do another one like this one that doesn't factor pretty. Example 4. What if I gave you 0 equals y squared minus 40? Same thing, I want that y squared by itself, so I'm going to add 40 to both sides. And I'm going to get 40 equals y squared. Then to cancel out this square here, I'm going to take the square root, and anything I do to one side of the equation, I must do to the other. This becomes plus or minus the square root of 40. This cancels to y. I cannot take the square root of 40, but I can divide 40 by 4. And I can take the square root of 4. And 40 divided by 4 is 10, and I cannot take the square root of 10. There are no factors of 10 that I can take the square root of. So I can simplify this, and I get plus or minus 2 root 10 equals y. So your two answers are the positive and negative version of 2 times the root of 10. Okay, let's do another special case, a perfect square. If you were to complete the square in an equation, and you ended up with an answer like this, x plus 2 squared minus 4 equals 0. Sometimes it would already look like this, x plus 2 squared equals 4, depending on how you completed the square and which method you were taught. Most of our problems will start out like this. If I've completed the square in my quadratic, which you don't know what that means yet, we'll talk about it later, then you would end up with a binomial squared equals another number. Well, I can cancel that square in the binomial by taking the square root of both sides. And when I do that, this square root will cancel with the square, and I'll be left with x plus 2. On the right-hand side, I have plus or minus the root of 4. In this case, that simplifies. The square root of 4 is 2. So then I need to move this 2 to the other side by subtracting. And when I subtract, I cannot subtract it directly from this number, because you have to remember this is a positive 2 and a negative 2. So when I subtract it, I'll get x equals negative 2 plus or minus 2. I have to write it in front every single time. If you move anything from this side after you take the square root, you have to write it in front of the plus and minus sign, just like I did here. Now this is two answers. This is the answer of x equals negative 2 plus 2, or x equals negative 2 minus 2. Well, and that'll give me my two answers. Negative 2 plus 2 is 0. X equals 0. Negative 2 minus 2 is a negative 4. So I get x equals negative 4. That's what you would do if you had completed the square and created a perfect square trinomial. You would just take the square root of both sides to solve it out. Then we have one other example. If they gave me a super hard and not so much fun difference of two squares, like 16x squared minus 49 equals 0. In this case, I'm going to solve to get that x squared by itself. I'm not going to factor it like we normally do. Normally, you would take notice that this is a difference of two squares, and you would split it into the two binomial answers equals 0, and then you would set each of those factors equal to 0. But what I can actually do is I can move the 49 to the other side by adding, and I'll get 16x squared equals 49. Then if I divide both sides by 16, I get x squared equals 49 divided by 16. 16 does not go into 49. I cannot simplify. But what I can do is take the square root of both sides, because I can take the square root over here and the square root of the fraction. I'm going to add in my plus or minus sign. The square root of x squared is simply x. Then I have plus or minus, and I'm going to split this up. This is actually the square root of 49 divided by the square root of 16. Both of those numbers are perfect squares. I can simplify both of those. I can say that x equals plus or minus 7 divided by 4, because the square root of 49 is 7 and the square root of 16 is 4. Here are your two answers. It has one step less, I believe, than factoring and solving, but it's the same basic process. You'll get the same answers even if you had factor and solved.